The stars above us aren't just beautiful lights. They're ancient messengers carrying secrets from the beginning of time. Through their light, we can read the story of our universe, from the birth of elements to predictions about our cosmic future. When we look up at the night sky, we're actually looking back in time. The light from stars takes years, centuries, or even millions of years to reach Earth. Take our closest star neighbor, Proxima Centauri. Its light takes about 4 years to reach us, so we're seeing it as it was 4 years ago. The light from the Andromeda Galaxy? That's showing us how it looked 2.5 million years ago. This delay happens because light, though incredibly fast at 186,000 miles per second, still needs time to cross the vast distances of space. It's like each star sends us a cosmic postcard, and we're just now getting messages that were sent long before humans even existed. By studying this ancient light, scientists can figure out what stars are made of, how hot they are, and even how they move. It's like reading a detailed diary of the universe's history. When scientists study starlight, they're doing something amazing. They're reading the chemical recipe of stars without ever touching them. Here's how it works. When we split starlight using special tools called spectrographs, we see dark lines in the rainbow pattern. These lines are like fingerprints that tell us exactly which chemical elements are in the star. Hydrogen leaves one kind of mark, helium another, and metals like iron leave their own unique patterns. It's similar to how each barcode at the grocery store represents a specific product. This technique helps astronomers discover that stars are mostly hydrogen and helium factories, cooking up heavier elements inside their hot cores. The really cool part. This same method helps us find planets around other stars and even tells us what distant alien atmospheres are made of. We can learn all this just by carefully studying the light that reaches Earth. Stars are like the universe's oldest libraries, each one storing information about different times in cosmic history. When we study really old stars, we can see what the universe was like billions of years ago, because these stars still contain the original materials from that time. The oldest stars we've found are about 13 billion years old. They formed when the universe was just starting out and only had simple elements like hydrogen and helium. Younger stars tell different stories. They're made from materials recycled from previous stars that exploded, so they contain more complex elements like carbon and iron. By comparing stars of different ages, astronomers can piece together how the universe changed over time, kind of like reading through different chapters in a history book. It's amazing to think that just by studying the stars above us, we can understand how our cosmic neighborhood has evolved since the beginning of time. When astronomers study starlight, they're basically reading a cosmic version of Morse code. Each star sends us messages through its light patterns, telling us its life story. The light from a star splits into a rainbow-like pattern called a spectrum, and within this pattern are dark lines, gaps where certain colors are missing. These gaps appear because specific elements in the star absorb particular colors of light. Think of it like a barcode. Each element creates its own unique pattern of lines. By reading these patterns, scientists can tell exactly what a star is made of, how hot it is, and even which way it's moving. For example, if the lines in the spectrum shift toward red, it means the star is moving away from us. If they shift toward blue, it's coming closer. This simple but powerful technique has helped us discover thousands of planets around other stars and map out how galaxies move through space. Let's explore one of the most dramatic events in space: supernovae, the explosive deaths of massive stars. These cosmic fireworks are so bright they can outshine entire galaxies and be seen across vast distances. When a large star runs out of fuel, it collapses and then explodes, sending elements like carbon, iron, and gold shooting through space. Without these explosions, we wouldn't have many of the elements that make up Earth and even our own bodies. Scientists can spot the remains of supernovae that happened thousands of years ago. For example, the Crab Nebula we see today is leftover debris from a supernova that Chinese astronomers recorded in 1054. These stellar explosions act like cosmic recycling centers, spreading the building blocks of life throughout the universe. Each new discovery of an ancient supernova helps us better understand how the elements around us were created. Let's zoom in on our cosmic backyard and meet some of our stellar neighbors. The closest stars to Earth each tell fascinating stories about how different stars can be. Take Alpha Centauri, a family of 3 stars just 4.3 light-years away. 2 of these stars dance around each other like cosmic dance partners, while the third, Proxima Centauri, orbits them from far away. Just a bit further out, we find Sirius, the brightest star in our night sky. Though it looks like one bright point of light, it's actually 2 stars, a large hot star and its tiny dense companion called a white dwarf. Barnard's star, another close neighbor, moves across our sky faster than any other star we can see. These nearby stars are like friendly neighbors who help us understand how stars live, age, and interact with each other. Now let's explore one of space's biggest mysteries, dark matter, and how ancient stars help us understand it. When astronomers watch how stars move in galaxies, they notice something odd. The stars move way too fast for the gravity of visible matter to hold them together. It's like watching a merry-go-round spinning so quickly that the horses should fly off, but somehow they don't. This led scientists to realize there must be something else out there, invisible dark matter, providing extra gravity to hold everything together. By studying the motion of old stars at the edges of galaxies, scientists estimate that dark matter makes up about 85% of all matter in the universe. Think of dark matter like an invisible frame that shapes our cosmos, affecting how galaxies form and grow over billions of years. Let's explore how stars act as cosmic factories, creating the building blocks of everything we see around us. In the early universe, there were only 2 elements, hydrogen and helium. But inside stars, these simple elements combine under extreme heat and pressure to make heavier ones like carbon, nitrogen, and oxygen. When massive stars explode, they scatter these elements across space. The iron in your blood, the calcium in your bones, and the gold in jewelry. All of these were cooked up in ancient stars billions of years ago. It's amazing to think that every atom in your body, except hydrogen, was once inside a star that died long before Earth existed. Stars truly are the mothers of all elements, turning simple gases into the rich variety of materials that make up our world. When we look at distant galaxies, we're seeing the light of stars that might not even exist anymore. They're like cosmic ghosts sending messages across time. Some of these stars died billions of years ago, but their light is just reaching us now. For example, when we observe the Sombrero Galaxy, we're seeing stars as they appeared 29 million years ago. Many of those stars have already exploded as supernovae, but we won't know about it for millions of years. It's like watching a delayed broadcast of cosmic events. By studying this ancient light, astronomers can piece together how galaxies evolved and how stars lived and died in the early universe. The light from these long-gone stars helps us understand our own cosmic history and the incredible journey of matter through space and time. The stars we see today give us amazing clues about what's coming next in our cosmic story. By watching how stars age and change, scientists can predict what will happen to our sun about 5 billion years from now. It will swell into a red giant, then shrink into a white dwarf. Looking at the motions of stars and galaxies tells us our Milky Way is on track to crash into Andromeda Galaxy in about 4.5 billion years. The expanding universe, which we can measure by looking at distant starlight, suggests everything will keep spreading apart faster and faster. Some stars will keep burning for trillions of years, while others will fade away. These cosmic patterns help us map out the possible paths our universe might take, from the fate of our solar system to the ultimate destiny of all the stars we see. Thanks for joining us on this cosmic journey through ancient starlight. Every twinkle above tells a story billions of years in the making. If you enjoyed exploring space with us, hit that like button, subscribe for more stellar adventures, and share with fellow stargazers.